Okay, gang, we're going to use the intermediate value theorem to verify that this function has an output of 2 on the interval. So remember, you have to do the 3 conditions that I asked you. So the first condition is that the function is continuous on the interval. And again, the reason why we do that is that this is a prerequisite to using the intermediate value theorem. If the function is not continuous, you can't use the theorem. Right, and of course I'm going to give you something that's continuous on the interval, otherwise you can't do the problem. So that's the first thing I'm looking for, that you're showing that you know that the function has to be continuous to apply the theorem. All right, step 2 is that you're given the interval, meaning you're given the first x and the last x, but you need to know the output values because you need to be above and below this particular value. So we're going to plug this into the function. And by the way, this is a parabola, so this function is continuous everywhere, so it doesn't really matter where you cut it. All right, so the first input value is a -1. Okay, so that's going to give us out a -8. Okay, and the last output value is a 10. So whatever part of the parabola we're on, we know that the height goes from a -8 to a height of a 10. So the question is, so whatever segment of the parabola we're on, we know that the height goes from a -8 to a 10. So the question is, are we going to cross a height of a 2? Do we have a 2 on this interval? And as you can see, we do. We have a 2. So now we're going to invoke the intermediate value theorem to guarantee that we have a 2, because if this function is continuous, if it's missing no values in between -8 and 10, then it must at some point cross a 2, right? That's the logic. All right, so since we're below the value we want, up to, since we're below the 2 and we're above the 2, okay, since we're below the 2 and we're above the 2, the intermediate value theorem, and again, you can shorthand this on the test, that's fine. The intermediate value theorem guarantees that there must be at least one value of C such that f of C equals to 2. Since it's a parabola, there'll just be one value of C. This one won't oscillate in between those domain values. All right, so again, I'm looking for you to say it's continuous. I'm looking for the output values. I'm looking for you to invoke the intermediate value theorem. All right, and for those of you who want to know exactly what x value has that height of 2, let's just see if that can be done quickly. So it's basically asking, where does this parabola equal to 2? And let's just see if this can be done quickly. If not, I'll just can it here. All right, we're going to subtract 2. Let's see if this factors. It has to multiply to a -6. So if I do a -1 plus a 6, that would add to 5. All right, so x is 1 and -6. Now look at these answers. Mathematically, if I had started with this, they're both correct. But in the context of this problem, they're not both correct. Okay? So which one is the correct answer in this context when x is 1, right? Because -6 is not in this interval. We're only looking at a particular segment. So the only answer here is the 1. So the point is 1, 2. That's the xy value that we're crossing. All right, gang, that's it on this one. I'll catch you. Bye-bye.